Hey guys, welcome to this video for question 3 for the 2016 level 3 integration paper. So question A, find the value of k if the indefinite integral of 4 plus k over x squared dx between x equals to 4 and x equals to 1 equals to 0. Alright, so first things first, we're going to integrate our function. So we're going to say integral 4 of 1, 4 plus k, we move the power to the numerator, so x to the power of negative 2 dx. And now we're just going to apply the power rule, so this becomes 4x minus k over x between 4 and 1. And this we know equals to 0. So therefore 16 minus 4 over, so 16 minus k over 4 minus 4 minus k over 1, that equals to 0. So we get that 12 plus 3 over 4k equals to 0. So therefore, we should get that our k value, k should come out to be negative 16. And that should be our final answer for this question, and this is a achieved question. Question B, use values given below to find an approximation for the indefinite integral between 4 and 1, f of x dx using Simpson's rule. So on our formula sheet, we should see Simpson's rule. So that's just the approximation for the area underneath the curve. Sorry. Sorry, something stuck in my throat. Okay, sorry about that. So Simpson's rule, that is, if I write it down from formula sheet, it's b to a f of x dx equals to 1/3 of y0 plus yn, and then plus 4 times of every even one, so y2, y4, y6, and then 2 times of every odd one. And this is h here. So h we know equals to b minus a over n. And we know that in this case b equals to 4, that's our upper range, a equals to 1. Therefore our h equals to 3 over n, and n is the number of terms, but n is even, so 1, 2, 3, 4, 5, 6. So n equals to 6 in this case. Alright, so in this case we'll have that this equals to h, which is 1 over 2 times 1 over 3. y0 is 1.4 plus 1.8. That's the two values on the edge, so that's this value and this value. Plus 4 times of 2 plus 3.8 plus 2.2 plus 2 times of 3 plus 2.8. Alright, so let's plug this all in. So we should get... 3 plus 2.4 plus 1.4 4 plus 1.8. Alright, divided by 6. So you should get this equals to 7.8, and that is an achieve level question. So that's another U grade there. Question C, use integration to find the area enclosed between the graphs of the function y equals to 2 minus x squared and y equals to negative x. Alright, so we want to find the area enclosed between the graphs of the function y equals to 2 minus x squared and y equals negative x. So best things first, we should probably draw these two graphs out to get a visual understanding. So we have our axes here. Negative x should look something like this. That's our constant gradient. And 2 minus x squared, that should be a negative parabola, and that's x squared equals to 2. So therefore it should intersect at, so x equals to plus or minus 2. So I just made y equals to 0 to find the x-intercept. So in this case, x equals to plus or minus 2, square root of 2, sorry. X square root of 2, so I have square root of 2 here. Square root of 2 here, that's negative. Alright, so it should look something like this. Alright, so that's our graph. So we can see that our parabola is actually on top of our the linear graphs, and we're going to find the 2 points of intersection. So we're going to say that 2 minus x squared equals to negative x. So therefore 0 equals to x squared minus x minus 2. So therefore we plug into our calculator, so 1, negative 1, 2. We should get x equals to 2 and x equals to negative 1. So that will be our x equals to 2 there, and this will be our x equals to negative 1. And therefore, the area enclosed would be equal to indefinite integral of 2 and negative 1. And the top graph minus the bottom graph, in this case, is the parabola, which is 2 minus x squared minus negative x dx. So area equals to, so 2 minus x squared plus of x dx. And this becomes 2x minus x cubed over 3 plus x squared over 2. That's just our power rule between 2 and negative 1. And this should give us, we just need to plug into our calculator right now. So once you show your integral, you can just go with your calculator. So we can go option, calc. Should get an answer of 4.5, so 9 over 2. So we should get an area of 9 over 2, and that is a merit level question. So that's with your 9 over 2. To get a achieved mark, you're looking at correct integration. So correct integration is an achieved. So if you can get up to here, that's an achieved grade there. Find the integral of e to the power 3x minus x squared divided by e to the power 3x minus x cubed. Okay, so for this case, this is a common ln problem. So we're going to find the derivative of the denominator. So derivative of e to the power of 3x minus x cubed, that equals to 3 e to the power of 3x minus 3x squared. So if you can notice that the numerator here has exactly 1/3 of everything of this derivative. Because if we find, find the derivative of ln of e to the power 3x minus x cubed, we will actually get 3 e to the power 3x minus 3x squared over e to the power 3x minus x cubed. So notice that what we actually have in our integral is exactly 1/3 of whatever we had in our numerator. So what we actually had before is obviously a 1 over 3 in front. And that will actually just be it. That's our integral. So we found that it's a 1 over 3rd. So this is just the reverse chain rule. So you should get that this equals to ln of e to the power of 3x minus x cubed, 1 over 3 at the front, plus of c. And that is a merit level question. Actually, that's actually a merit level question, and you can actually only get a merit grade for this question. There's no achieved for this question. So this was a merit level question. Alright, so question E, if secant x times dy over dx equals to y, e to the power of y plus sine x, and y equals to negative 1 when x equals to 0, find the value of y when x equals to pi over 2. So in this case, we have our x and our y, so we need to group the dy and y together and x and the dx together, and then integrate on both sides to find our y. So therefore, we'll just write down the question again. So we have secant x times dy over dx, that equals to e to the power of y plus sine x. Alright, so you know when we have e to the power of, when we have something to the power of something plus to the power of something together, we can actually split it up and say it's multiplying, okay? So we can actually rewrite this as secant x times dy over dx equals to e to the power of y times e to the power of sine x. So when you multiply same base with the powers, you add the powers. So you can, likewise, you can split them up again. Alright, so in this case, we're going to move the e to the power of y to the other side. So we have 1 over e to the power of y times secant x dy over dx. That equals to e to the sine x. Right, so now we're going to move the secant x to the other side. So 1 over e to the power of y times dy over dx. That equals to e to the power of sine x over secant x. And now we're going to move our dx times dx on both sides. So 1 over e to the power of y dy equals to e to the power of sine x over secant x times of dx. So we know that 1 over secant x, that equals to cos of x. So this can be rewritten as 1 over e to the power of y dy, that equals to cos of x e to the power of sine x dx. Right, so now we're going to integrate on both sides. So e to the power of negative y dy equals to integral of cos of x e to the power of sine x dx. Right, so let's look at e to the power of negative y first. So you're going to divide by the derivative of the power. So divide by -1 gives us negative e to the power negative y. Power stays the same. So this becomes negative e to the power negative y, and that equals 2. Alright, so we know that the derivative of sine x is cos x. So we had e to the power sine x, and the derivative of e to the power sine x is cos of x, because we multiply by the derivative of the power times e to the power sine x. So this is simply just equal to e to the power of sine x plus c. Alright, so now we know that y equals to -1 when x equals to 0. So negative e to the power of -1. E to -1. So negative y, that equals to 1. So negative e to the power of 1, that equals to e to the power of sine of -1 plus c. Plus c. My pen is... Alright, so plus c here. Alright, so we plug that into our calculator. Oh, sorry, when x equals to 0, I apologize. X is 0. So sine of 0. Sorry, my Apple Pen is just broken, so I don't know what's going on. So apologize for the messy writing, but sine of 0 gives us 0. So this actually gives us negative e to the power of 1. That equals to e to the power of 0, which is just 1, plus c. So therefore, we get our c equals to negative e to the power of 1 minus 1. Alright, so now we're going to substitute x equals to pi over 2. So therefore, we can say that negative e to the power of negative y equals to e to the power of sine of pi over 2 minus e to the power of 1 minus 1. So sine pi over 2, that equals to 1. So negative e to the power of negative y, that equals to e minus e to the power of 1 minus 1. So that just cancels out. So therefore, we will get that e to the power of negative y equals to 1. Take the ln of both sides, we get negative y equals to ln of 1. So therefore, we'll get that negative y equals to 0. Therefore, y equals to 0. And this is a excellence level question. Excellence level question here. So this will get you in T grade here. If you can get y equals to 0. To get a merit grade, you'll get integration of both sides. So integration of both sides up to this step here. That will get you a merit grade. To get an achieved grade, you're looking at correct integration on one side. So either here or here. That will get you an achieved. Alright, so sorry about my Apple Pen being breaking down at the end there, but I hope you enjoyed the video. If you did enjoy the video, please drop me a like and comment down below if you have any queries, and I hope to see you on the next one. Thank you. Bye.